Okay, real quick, this lesson should be relatively fast. We're doing multiple representations. We're still talking about the ratios, the rates, proportions, your x-axis, y-axis, and order pairs and the origin. So when you get in today or before you start, work on a little bit of your diag action plan. Okay, next, we're going to be looking at the explore section. So the directions here say the graph shown represents the number of gallons of water used for a number of times a toilet is flushed. Use the graph to answer parts A through D. Okay, so we have our water in gallons over here on our y-axis, and you have our flushes over here on our x-axis. So what you're going to do is, A says, write each point on the graph as a ratio of gallons of water used, number of flushes. So our ratio is gallons of water used to number of flushes. So first, our first point here, it's at, this is 1, 2, 3, 4, yep, 5. So this is 1, this is 1, 2, 3. So our first point is we used 3 gallons for 1 flush. That's this point here. Second point here, we used 6 gallons for 2 flushes. Point here, we used 9 gallons for 3 flushes. And then our last point up here is 4 gallons. Well, I'm sorry, 12 gallons, 4 flushes. Okay. And then B says, how many gallons of water would be used if the toilet was flushed 8 times? Explain your strategy. So we can set up a proportion or a table. I'm going to set up a proportion. We have 3 gallons to 1 flush. And our proportion, we want to know if we flush 8 times, what will we get? All right, and that would be X here. So here to here would be times 8. 1 times 8, here to here, we do the same. So we end up with 24 gallons. I used a proportion to find, whoops, to find with 8 flushes, you would use 24 gallons. So again, we did our times 8 as our scale factor. We use it says how many flushes would occur to use 18 gallons. Okay, so we can also set up a similar proportion. We can just do it here. Let's just do it over here. So 18 flushes. Oh no, 18 gallons, sorry, not flushes. So 18 gallons would be, so if we put 18 gallons and we don't know the flushes, we can use the same proportion, 3 and 1 flush. So look how we go from here to here. You can divide 18 by 6, or you can multiply. We can multiply this by 6, right? 3 times 6 is 18, so you do the same thing here, times 6. So it would be 6 flushes. So same thing, using a proportion. I solved for x in gallons would be 6 flushes. Did you use the same strategy for 2 and 3? If not, why? Yes, I used the same strategy. All right, there are many ways to represent proportional relationships. Okay, so that's what this whole lesson is talking about, is really how can you write proportions differently and how will you see them throughout the test. So we've seen ratios. We did a whole lesson on that. So you have the words right here, 5 soccer balls to 3 soccer balls, with the colon in the middle. You also have the words with only words, 5 soccer balls to 3 soccer balls. 3 footballs. Then you have the fraction form here. And then you have a sentence written out. There are 5 soccer balls for every 3 footballs. Okay. Similarly, ratio table is telling you the same information. You got 5 soccer balls, 3 footballs, but you also are figuring out here. Look, they use a scale factor of 2 to go from 5 to 10. So they did the same scale factor here to 2. There you go. Then this one here, they use a scale factor of 3 to get from 5 to 15. Here they use a scale factor of 3. 3 times 3 is 9. So that would still proportional to our given ratio. Okay, here's our visual representation. They drew the 5 soccer balls, 3 footballs. And key point number 2, the x-axis and the y-axis each represent a data set, or set of data, sorry. So if we look here, this would each represent a set of data. We have number of soccer balls here, so this side here should be, sorry, Siri started talking. Number of footballs. Okay, and that's going to be on the y-axis. Sometimes they would give you both, but in this case, they gave us number of soccer balls, so we know. So number 1 says, what does the x-axis represent in this problem? That is soccer balls. And the y-axis is, we're talking here, this is footballs. So now they want you to plot the following ratios on the coordinate plane. So we'll do A in blue. So 5 soccer balls, 3 footballs. So 5 soccer balls, because that's our X here. And then 3 football. Okay, and if we label our point, we get 5, 3. Remember, X always goes first. Now in purple, we'll do 10 soccer balls and 6 footballs. So 10, 6. 10, 6. And then in green, we'll do this 15, 9. Remember, what we're doing is starting at 0, 0 here. And we're traveling along till we see 15. And then we go up until we get to 9. And there is our 15, 9. All right, that's how you plot the points. A lot of us learned this yesterday, so it should be review. All right, for this one, it says Jefferson reads 6 books for every 2 months, and they want you to draw a picture. People's pictures will look different. For the months, I guess we could make something that looks like a calendar. That's my calendar. So, not exactly the same, but calendars, we'll call those months. And then books. My books. We'll call my cubes books. Probably should pick something faster to draw, but using my books. Okay. to be super pretty. It's just a visual. 1, 2, 3, 4, 5, 6. So there you go. So now solve the proportion to find out how many books Jefferson will read in 18 months. Again, proportions, we're looking for that scale factor. You go times 9 here to go from 2 months to 18 months. And then you have to do the same on the top. And then our 9 times 6 is equal to 54. So he would read 54 books. Make sure you remember to put units. Okay. There you go. So now you can use the same way to complete the table. It's looking for your scale factors, okay? So when we're talking here, we can look at, okay, how do we get from at 0 months, look, we're gonna have 0 books, right? That's like our origin. To go from here to here, we would divide by 2. Here to here, we can divide by 2. 6 divided by 2 is 3. Now we can also go, all right, 6 to 36, we can do times 6. And you can work these in whichever order makes sense to you. 2 times 6 is 12. Okay? So now we have this guy here. So now we got to figure out the same proportional relationship. This one is a little bit more tricky. We're trying to go like 2 to 9, things of that nature. But what we can do is use our unit rate, which is here. Okay? And we can go from 1 to 9. That'll be times 9, right? And then from 3 to our blank, we do the same. Times 9. 3 times 9 would be 27. Okay? There you go. 27. And we got our table completed. Now it says use the values you found above and plot the coordinates on the graph. Let's do that. All right, so let's fill in our table. 0 we know is 0. 1 was 3. 6. 2 and 6. Oh, we already got that. And then, we didn't find out 6. We have 9, 27, 12, and 36. 9 and 27. But we also can find this one too. We could do times 3 and times 3. That would be 18. Okay, so let's look at that now. So now when we're talking, putting the points in, we can treat those as X and Y to go ahead and figure out what we need. So look at your points. 0, 0, that's going to be your origin, right? And then after 0, 0, you're going to just put those points in. So 0, 0, that's going to be our origin. 1, 3. 1 is our X, remember? So here is 1, 3. I did that one in blue. Purple, 2, 6. 2, 6. Yellow, we'll do 6, 18. 6 is in between 5 and 7. 6. And 18, 12, 13. This would be 9. And what's in between? Look, they gave us a weird graph here, but I mean, it is what it is. So 9, 10, 11, 12. So this is kind of like 10.5. So, every 3 it goes up. So this top one would be 15. Because 9, 10, 11, 12, 12, 13, 14, 15. So really 6 will be, if you go travel up here, 6 will be somewhere up here. And the same thing for R9. It's going to be completely off the graph. Like, it's going to be way up here somewhere. Okay. So it's kind of that. But you can plot your first 3, all right? All right. Let's work out a couple of these elaborate questions for you real quick, and so you can get your IXL done. So it says Anna burns 225 calories per 30 minutes of bicycling. So your given ratio, 30 minutes, 225 calories. So we can use our scale factors again to build these relationships. To go from 30 to 10, we can divide by 3. Same thing here. We would take 225 and divide it by 3. 7, 21, 1. Bring your 5 down. Now we have 5, 15, 0. So this one would be 15. Oh, no, not 15. Sorry. It's R up here. 75. I was working too fast. So 75 calories burned for 15 minutes, right? And what I would do, honestly, now is you can just take your first right here, and then we can do scale factors to 50 and to 60. So coming from here to here, it would be a times 5. So here to here would also be times 5. So 75 times 5, 25 here, 35, 36, 37. So this would be 375. And then we can do something similar with going from 10 to 60 would be times 6. So we're going to do the same thing. I'm running out of space here, but same thing would happen to go here. That would be a times 6. So 75 times 6, 30, 42, 43, 44, 45, 450. All right. So now what you can simply do is plot those points. We know that calories burned is our Y. Look at it here. And your time is your X. So 10. And if you look at these, they're in increments of 25, 50, 75. So you have to be able to recognize that on your graphs as well. So our 75, I'll do it in red because that's what color it is. So 10 and 75 here. 30 and 225. So my 30 goes up to this. Here's my 225. 50 and 375. So sometimes you have to maybe draw a little line up so you don't get lost in these little lines. There's my 375. And my 60. I'm going to draw a little line up because we're trying to go all the way to 450. There you go, 450. Here we go. And there's our line. So we set up our table. Good to go. All right, last one. It says Morgan uses her typing skills to work on her research paper for history. When she hits print, she realizes that her printer is broken. For every 5 pages she attempts to print, the printer messes up 3 pages. So that was our given ratio, right? 5 to 3 pages. So now you just fill in the table like we did and finish the ratio. So here to here would be times 2. So here to here is times 2, which would give us 6. Here, to here, times 3. So here to here is times 3. Give us 9. And last one, here to here, times 4. Here to here, times 4. So 12. So it says create a graph for the values with the 4 ratios. Okay. Again, messed up pages, that's our Y, and here's my X. I know that because I look. Here's your 2 things here. So we'll do our first one in black. So number of attempted pages is 5, and it messes up 3. Okay. Attempted was 10. It messes up. If you need to draw your line, 1 above 5, 6. And we got 15 and 9. And we have 20. And here's 10, 11, 12. There's 12. Remember, sometimes if you need to, 11, 12, you can draw this line over to make sure you're in the right spot. There you go. Could the coordinate 30 and 50 be included in the graph? Explain your reasoning. Okay, let's see. 30 for X, 50 for Y equals, we can start with our given ratio. Ours is 5, 3. I would say no, looking at the back, because it looks like these two are flip-flopped. Okay. There's no, even if you check to see if it's proportional, this would be 90, and this would be 250. So they're not proportional. So no, because 30, 50 is not proportional to our other points. And that's it, guys. I can work your evaluate questions real quick for you too. Real quick. And the art club is taking a field trip. It's telling us every 3 tickets is 90. So you got to complete the table and graph them. So again, from here to here would give us, so we can find our unit rate, it would be divided by 3. So do the same thing here, divided by 3. So that means, if you don't know it by heart, 90 divided by 3, be 3 times 0, so 30. 1 ticket costs 30. So now you can use that relationship to find the rest. To move from 30 to 15, that would be times 5. So here to here is times 5, also giving you 5. If we go from 1 to 10, that's times 10. Same thing, times 10, you end up with 300. And the last one would be times 11. Do the same thing, times 11. So, if you don't know it, guys, just work it out. 11. Okay, so this will be 0, 3, 0, 3, 330. All right, then you just graph them. Okay. First one would be 130. So 130. Not going to do colors to save time. It would be 390. 390 is here, in between 60 and 120. So this is 30, and then 30 plus 60 is 90. So that's how this is going, like in increments of 3 or 30. 5, 150 here. 10, 300 here. And 11, 330. There you go. Notice how they kind of make a straight line. It says if Inga spends 660 on tickets, then how many tickets? You can use your proportion. 1 ticket is 30, and then if she spends 660, you want to know how much is that. So what you can do is figure out the scale factor here. You can also see the relationship that you have here, but if we do 660 divided by 30, this will be 260, get left over 6, another 2. So 22 tickets. There you go. Because we know that we finished that out at 0. All right, is there another page to this? That's it. That was all on your evaluate. So you should be good to go. All right.